Hi, in this video we are going to talk about the idea of collider bias. This is something that a lot of graduate students learn about, maybe a little bit, or don't learn about. I think it's really important and something that people should think more about, and especially in the social sciences. So this is borrowed. I'll share the paper, which I've just misplaced. Let me find it so that I can give credit where credit's due. This is an example from... The paper is called, Thinking Clearly. I'll put a link in it, but it's called Thinking Clearly about Correlations and Causation, Graphical Causal Models for Observational Data by Julia Rohrer. It was shared by Dr. Sean Baldry at Purdue in the class that I'm teaching, or kind of leading around research methods. So they give this example, and I wanted to build out the intuitions a little bit, actually do a simulation to show what collider bias is and how it works. And so in this paper, and I'll also give a link to the simulation so you can look at it. In the paper, they give the example of academic papers, which might or might not be published in journals. And the idea is there are sort of a vector of attributes that papers have, which contribute to whether or not they are published in a journal. And so some of these, and they give the examples of rigor and innovativeness. Obviously, we could come up with lots of other things as well. But the idea is that we might have a theory. Let's start kind of theoretically. We might have a theory that these two are related. That maybe we decide on. There could even be a third process, but we decide on how much rigor we're going to put in, and the more work you do in understanding methods, for example, like the amount of rigor that you have available to you to put into a paper influences the amount of innovativeness in the paper. In other words, there are people. There may be people who are methodologists who are very rigorous, and they've spent their time on that, and so they don't understand theory as well, et cetera, right? So they're not as innovative in what they do, right? So this is this theoretical world. We may have a theory that this link exists, that there's a causal link between the amount of rigor in a paper and the amount of innovativeness, and so we're looking for that, and we also know whether something has been published or not, and so. In this world, we might think that what we want to do is, we don't want to be biased by whether something's published. There's sort of this model in the social sciences that some of us have in our head that the more things you can control for, the better. That if you have a variable that's related to either your outcome of interest or your independent variables, you should just include it, and it can't hurt. Well, collider bias is a great example of why that is wrong or can be wrong. And so let's look at the setup of the world that we've created, that we're simulating. This is from R. So we have an N of 1,000 papers. Those papers are randomly assigned a rigor that is randomly distributed, random variable from random normal variable that's centered at 0 with a standard deviation of 1. They also have an innovativeness score, which is independent of that, right? It's another random normal distribution centered exactly the same way, centered at 0 with a standard deviation of 1. And then there's a threshold. There's a lot of ways you could model this, but I just made the threshold drawn randomly from 0 to 2, so a random uniform distribution from 0 to 2. And so the idea here is that there is some noise in whether something gets published, that in general things that are better will be more likely to be published, but it's a noisy process. And so for each paper, there's sort of a threshold that's randomly determined. And if its score, that's what this published variable is, if its score, which is rigor plus innovativeness, is greater than the threshold for that paper, then it will be published. So we can see what this looks like. So there should be no true relationship, right? We created these variables randomly. They are not related to each other. And so that's what we see, that they're not related if we just naively try to plot them with all of both the published and unpublished data. So this is equivalent and I'll show this in just a second. This is equivalent to running a regression. So that's what this LM is, a linear regression model of innovativeness on rigor from our data. Oops, left a little bit of junk in there. And these are the estimated coefficients, right? So they're both very close to 0, as we'd expect. So rigor does not predict innovativeness. What was the other thing I was going to say? Yes, hopefully that setup makes sense. Oh, that's what I was going to say. You can see, right, that this is where the randomness appears. Anything sort of in this area could be either published or unpublished. It sort of is, it's innovative enough, innovative plus rigorous enough that it could be published, but the threshold happened to be either higher or lower. And then anything right above here is definitely published. Anything down here is definitely not published. And so when we then think, okay, that's great, let's add whether something's published as a control variable, right? Like that could help us to get a narrower estimate, a better estimate. Why not throw it in there? This is actually collider bias. And so the idea is, the reason is that both if we think of kind of causal diagram that we have, I should have drawn this out, but we have rigor on one side and an arrow pointing to innovativeness. Well, really, publication is actually pointed to by both of them, right? So both rigor and innovativeness influence whether this thing is published. And so what that means, that's the kind of the definition of a collider bias, is something that is influenced by both the independent and dependent variables. That's on paths both way. And so what that means is when we control for it, when we stratify by that, we will be misled. And so here's an example of that. I've just faceted, so it's the same plot where rigor is on the x-axis and innovativeness on the y-axis. Same plot, but now we have true in one facet and false in another facet of whether or not it's published. When we look either at the published or the non-published, we see that there appears to be a strong negative relationship. That when something is more rigorous, it is less innovative. And so if that was our theory, we have just found not just evidence, like proof. All right, evidence is probably a better word. We have found evidence that our theory was true, that there's a trade-off between rigor and innovativeness. And so that's what we then, publish. That's what we then write up in our discussion section, is that we see that if you have more rigor, you're going to have less innovativeness in a paper. That is, I just want to go back to this idea. That is not true. It might be true in the real world. That's possible. In this case, it is not true. We created this data to be independent, and it definitely is completely independent. They are not related to each other. When we look at a regression, right, here's what that would look like. Here's the 0 coefficient, or the 0, and right here's the 0 level, and here's our expected coefficient, or our estimated coefficient for rigor is that it's negative, pretty strongly negative. Right, so this is, we would definitely consider this, right, a statistically significant result, and yeah, we'd be off to the races, but we would be wrong. We'd be wrong. So that's why it's so important to consider. I really am going to, I think that it's important to consider the causal diagrams and consider the, things like collider biases. We know most graduate students learn about confounds, the potential of confounds. But if that's all you know about, it sort of makes sense that you'd sort of try to include everything. You have to understand the whole causal chain that you're trying to test, and where you could go wrong.